This is a video on differentiation. The definition of a differentiation is the process of finding the derivative or the gradient / slope of a function. So I'd like you to highlight. Differentiation is finding the derivative or the gradient or the slope of a function. There are a number of rules associated with differentiation, which we'll be getting to. These rules can be used to differentiate more complicated functions without having to resort to the tedious method of first principles, which we will not cover in our course. If you were in a traditional calculus class, you would get into that. So, differentiation, the following. Find the derivative of the following. These are all ways to ask the same thing. So if you see it as such, find what we say dy dx, the derivative of the function. Find an expression for the slope. Find an expression for the gradient. They're all the same thing. They're asking you to differentiate or find the derivative. So the first derivative rule is called the power rule. What you do to find the power rule is use this formula. To find dy dx, you would multiply the exponent by the coefficient to find the new coefficient. So you would take the exponent and multiply it to the leading coefficient. This is the same formula, just a different notation. Step 2 is you subtract 1 from the exponent to get the new exponent. All right, so we'll be doing some examples on the next slides using this step 1 and step 2. So step 1 again is to multiply the exponent by the coefficient to find the new coefficient. And then step 2 is subtract 1 from the exponent to get the new exponent. All right, this is an image of a gradient function. So if you remember earlier in our lesson, the gradient represents the slope of the tangent line, and it changes throughout your graph. So when we describe the gradient function, we're looking for the slope of the tangent line at that point. We call this the gradient function of the derived function, or the derivative of the function. The notation we can use is we say dy dx. Or if you have your function, the derivative is, we say that f dashed x. So here's an image of a function, it's a quadratic, and then you have all of these tangent lines. Here's a tangent line, here's a tangent line, here's a tangent line, here's a tangent line. You're looking for the derivative function or the slopes of those lines at those points. All right. So in the previous example demonstrates that the slope of any one point can be found by 2x. How do we find that? We're going to use the derivative function rule, the power rule. So here's that previous example. This is going to be the derivative function. So what we see for notations, f dashed x or dy dx, those are the derivatives of that quadratic. How do you find it? If here is your original function f of x, and here's x squared, what you do is you bring down that 2, so So that's now your coefficient, and now you subtract 1 from the exponent. So the derivative is 2x to the first. So here's our example again. So we're going to use the power rule. So here's your function, your quadratic. So we'll say f dash x. We're going to bring that 2 down. That's your new coefficient. Then we're going to subtract 1 from the exponent. So the derivative function is now 2x to the first, or just 2x. Example 2, new function, 2x to the fourth. So to find the derivative function, you have a 2, and now you're going to bring that 4 down in front, x, and then you're going to take 4 and subtract 1. Now we're ready to multiply in front those coefficients. So 2 times 4 is 8, x, and now 4 minus 1 is 3. So the derivative function is 8x cubed. All right, to find the gradient function, you differentiate the function using the power rule. So just a different way to say it, to find the gradient function, you're looking for the derivative function. We're going to use our power rule. So f dash x equals, we bring that 8 down in front, x, and now we subtract 1 from that exponent. So 8x to the 7th. So the gradient function is 8x to the 7th. All right. Find the gradient function for example 4. We're getting a little bit more challenging because we have that 2 divided by x cubed. So what you have to do is you have to bring that x cubed back up. So you're going to change that to a negative power. All right, now we're ready to use our power rule. So I'm going to write it as dy dx equals, bring that negative 3 down in front, x, and now we're going to subtract 1 from the exponent. So this equals 2 times negative 3 is negative 6, x to the negative 4th power. So the derivative function is negative 6, x to the negative 4th power.